Again, one of the good parts of this unit is the fact that in this unit, like pretty much all of it revolves around a times b to the x power, which I normally don't write it like that the math way. I write it over and over, as you'll see on the next slide, as starting point. I'm going to abbreviate here. Rate of change, which is generally 1 plus or minus the rate of change, and the exponent is time. Most of the questions revolve around that. In Math 1, you learned about this, but in Math 3, we take it to some higher levels. Today, will really just be a review of the Math 1 level, kind of like we did basic volume, and then we did Math 3 level volume. Anytime your rate of change is greater than 1, as you saw in the warm-up, that's going to be an increase. Your number is going to go up. Whatever you started with will go up. And if your rate of change is less than 1, that's going to be a decrease. Whatever number you started with, it'll go down. Also remember, calculator doesn't like percent signs. Well, that's how I like to say it anyways. We don't do percent signs in math class. We convert them to decimals. And we convert it to decimal form by, as you saw in the warm-up, moving the decimal place twice. The starting point is always that A, and the rate of change is that B. Whatever time you're dealing with is that X. At the bottom, hopefully you can recognize that these two statements are the same statement. One of them is already written with like a percent form, already added, subtracted, like on this side with the 1 minus. It's showing you, hey, I started with 100%, I'm losing 13%. I'm writing losing 13%. In the other version, you don't see the 13, but you need to be able to recognize. If I'm under 1.0, I'm losing something, I'm decreasing. And how far am I under 1.0? I'm 0.13 below. I'm below 1 by 0.13. Both of them are saying the same thing. It's just a different way of stating the same thing. Sometimes you're given one form, sometimes you're given the other. You don't got to convert back and forth. You need to recognize the difference or the similarity anyway. Bless you. So I get it. A lot of us don't generally like word problems. It's not really the word problem that is what your panic should be. It's the fact, do you understand the setup or not? We've seen word problems before in this class. We'll see more of them. We're always going to follow y equals the starting point and 1 plus or minus the rate of change and raise it to time. So you just got to be able to read and tell what parts you have. A cup of coffee is initially at a temperature of 94 degrees. Where do you think that's going to go? Thank you. That's the starting point. Initially is a beginning. The difference between its temperature and the room temperature of 70 decreases by 9% each minute. So that was a big word, decreases. I'm going to write 1 plus or minus. Thank you. How am I going to put in 9%? I like 0.09. A lot of times I don't put that first zero. You're perfectly right. Remember, I moved the decimal place how many times? Twice. Always get rid of percents. Write a function describing the temperature of the coffee as a function of time. Now note, we were never told to find like the temperature of 4 minutes or 8 minutes. So we're just going to put X for our temperature. I'm sorry, our time. We know the temperature is not. So the temperature, by the way, is never going to go below 70 because the temperature in the room is 70. Like, it's not going to freeze. Obviously, if I put a glass of water on the table over here, it's not going to freeze right now. Some days it might freeze in here. If I go to Desmos and look at that, I'm going to type that in exactly as is, exactly as we wrote it. Y equals 94, 1 minus 0.09. So I see it going down, raise it to time. I don't see anything right now because it's starting at 94 and I'm only looking at 8. So normally, a lot of y'all are just going to zoom your way out until you find it, though I'll show you some better tricks. starting point is also the y-intercept, as you'll hear me emphasizing a few times. I'm crossing the y-axis at 94, and you see it's definitely going down. You can track it by minute if you want to. At 3 minutes, the temperature is down to about 71 or 70. And again, it won't go below 70 because the room temperature is 70, but we didn't put that in at this point. The main thing is, could we write the model to set it up? That's the model right there. Always starting point, rate of change in time. Because what happens to the model as we go through the unit, just minor things will happen to the model. Same one or same type of situation. Those of you in the health science classes may find this a little interesting. Anybody that takes medicine should find it interesting. I'm a little uncomfortable using a medicine and a dosage problem, but this came straight off the EOC website, so I'll blame them. But anyways, if an adult takes 600 milligrams of ibuprofen, the amount remaining in their system could be modeled by 600 0.72, and they have T for time up there. Which one of those numbers is the y-intercept? Thank you. Y-intercept is the same as what again? Starting point. And they also asked here, what does it represent? It represents exactly what y'all just told me, starting point. As soon as you take that medicine, you got 600 milligrams in your body. Now, is it going to stay 600 all day long? No, it's going to dilute. You're going to drink water. You're going to use the restroom. I don't know exactly how all that works, but that 600 goes down over time. And then when it's down to a safe amount, you can take more medicine if you need to. At what rate is the body eliminating the drug? Keyword rate. I like it. I'm going to write 0.72 first. And I'm going to put, or how much is that of a decrease? So I'll take that as well. Now we can give our answer in percent. We just won't do calculations in percent. 28% decrease. You can say that as a decimal if you want to. That's fine. To be specific, and we don't operate with percentages. We change them to decimals. Talk about them, sure, all day. 0.72 and 28% decrease are representing the exact same thing. On what interval of time, last question here, on what interval of time will there be at least 100? So we started at 600, and we want to know how long it's going to be 100. So what I did on Desmos, I just added another line, and I said y equals 100. And so now I can see that line with my original function. The red function represents the medicine each hour. It looks like it's down around 450 after an hour, and then after 2 hours, it's around 300, and then down around 200. And at about 5.5 hours, right here, it goes below 100. So that's usually when the medicine bottle tells you can do what? You can take more, right? It's safe to take more. Have a good lunch. A few minutes. So last we were talking about how from here to here, from the starting point to right here, this is the interval where we're above 100. I put in y equals 100, which is this blue line. Now that interval is kind of like a mini domain. That interval would go from 0 to 5.5. So it's again like a start and a finish from left to right. That was the last question there, C, that I hadn't mentioned. Last we had talked about 0.72 is the same as a 28% decrease. Here's some delta samples. These are not on your paper. Like the deltas can or will be really simple. Like it'll ask you maybe the starting point 600, but this one is just asking you, is it growing or decaying? It's clearly decaying, and it's decaying 25%. So you'll just literally flip that from growth to decay and type in what the decrease is. If it asks you to do 10% of 150, you just do 150 times what? 150 times, thank you, 0.10 or 0.10 if you want to do 60% of 150 multiplied by 0.60. You don't really need either one of those zeros. This bottom one is super important though. Make sure you understand the difference between ones that are linear, ones that are exponential. The question just wants to know exponential decline. Which one has an exponential decline? A radioactive compound decaying at 8%, is that exponential? 8% is definitely exponential. Any kind of percentage increase or decrease. And it did want to decline, so decay looks good. This is the first answer. This is the answer, but I'm going to explain the wrong choices. A town's population is growing 5.3. So this one is also exponential, but the problem with this one is growing. Elevator descends, so we like that part. 20 feet per second, is that exponential? If something's going up over and over the same amount, that's linear. And then finally, a coin collection appreciates. Is appreciate going up or down? Yep, that's up. Depreciate would be going down, so we don't want that one either. We wanted the decline one. So definitely one of my favorite sixes where you just have to read and analyze which one is exponential. You're looking for some kind of multiplier, like a multiple of 8%, in that case, 1.08, or doubling could be like times 2, or tripling. All those would be exponential when you're multiplying by something that makes it exponential. So real simple scenarios that you'll see in Delta. Town has a population of 5,000 and grows at 4.1% each year. What will be the town's population in 20 years? So we're actually going to do the calculation. You need, as always, starting point, rate of change, and time. Finish strong with me. Participate. What's the starting point? 5,000. It's growing, so I'm going to write 1 what? Yep, 1 plus 4.1% is 0.041. And this time, we know the x. We know the time is 20. So that's literally what I'm going to type in. It's going to be a decimal. You're going to have to round. It's going to tell you to round to the whole number, or tenths place, or hundredths place, which is why you have a rounding delta from time to time. I'm sorry, Gabe. So understand what's so important about that 1 you're seeing every time. That 1 is going to get you your original amount back. 1,800 times 1 gives me my 1,800 back, and then I'm going down 0.282% off that. I literally just type these in decimals for the answer. You won't see a line. Anybody know what's missing that we won't have a line on decimals? We'll just have an answer. These setups don't have an X in them, which is why you don't get an actual line, which is fine. We just want the answer. Any questions? Close to finishing up. This is definitely the best slide. If anybody was going to miss anything, it'd probably come from this slide. I'm short on my video time, so I'm going to kind of just answer the questions. They want to know about f of x and what's the y-intercept. Boom, it's crossing at -3 right there. Sorry if your graph isn't perfectly clear. The one over here, though, the y-intercept is definitely hiding well. If I write starting point, rate of change, and time and try to line that up, I know that x is the time, so that means 2 is the rate of change. Best question all day long. What number is here in the front if it ain't no number? Thank you. That's a 1 that's multiplying with it, right? And that 1 is your starting point, right? The starting point is your y-intercept. So there's many semesters where I left the answer at 1, and that was some good work. But focus on this -7. Remember, this -7 by itself on graphing days, this -7 has always been a downshift of 7. So from 1, our y-intercept shifted down 7, and it's now at -6. So again, a little advanced there. Best question of the day, how that y-intercept is -6. And then the final question here is, how far apart are the two y-intercepts? Well, one of them's at -3 and the other one's at -6. How far apart are they? They're 3 units or 3 blocks apart. Can distance ever be negative? Nope. I say how far is something. Can it be negative? Nope.